Hello, everybody. Welcome to 3.2 Least Squares Regression. Uh, so one of the things we'll be talking about is remember when I showed you the video in class of how to find R and you had all that other information there? We're going to be talking about a lot of that other information, okay? And one of the things I showed you was the regression line. And what is a regression line? It is a line that describes how a response variable y changes as an explanatory variable x changes. We often use a regression line to predict the value of y for a given x. Okay, so that line, as you might have saw on your calculator, is y equals ax plus b, right? Of some sort. Sometimes calculators flip the a and the b, but either way, it gives you a linear line. And the purpose of it is that based off the data you're given, you can make a prediction with that line. And with our predicted value, as I said, keep in mind A and B, sometimes it can get changed. In the case of the formula that's in your book, we put B with X. Be careful when you're looking at your calculator. But anyways, value in front of X plus all plus A is equal to what they call Y hat, not A hat. Y hat, which is fun because it looks like a little hat on my Y. So what does this do? Y hat's supposed to represent the predicted value with the given x value. All of the three values are explained here, y hat, b, and a. Extrapolation is usually something that you probably saw a lot of in your algebra courses because there's always an example to help you predict what's going to happen with a given linear function or whatever type of function. And what this means is use of a regression line for prediction far outside the interval of values of the explanatory variable x used to obtain a line. They're usually not accurate. So if I was giving you a scatter plot with values between 0 and 100, and I asked you to predict what 200 was, this will be the example of that because 200 is so far outside of it. What is a residual? Residual is the difference between the observed value of the response variable and the value predicted by the regression line, which you can find by just doing the observed value minus residual. So observed value minus the value predicted is a residual. Okay, so let me say that again since I messed up the first time. Observed value is y, predicted value is the y hat. Subtract that, you get the residual. Let's do an example. Let's find and interpret the residual for the can that was tapped for 4 seconds and had 260 milliliters of soda remaining. You do need a little bit of information, and that's this equation right here, because this was from a problem that was on my textbook, not yours, unfortunately, given to us. So if we put in 4 seconds into our regression, oops, didn't mean to go up and down. So 4 in. What would come out? It would be 259.12 milliliters. Now the actual amount was 260 milliliters, right? So the residual would be what we actually found and what was predicted. Subtract them and you'll get 0.88 milliliters. So we can say that this can had 0.88 milliliters more than expected. Least squares regression line of y on x is a line that makes the sum of the squared residuals as small as possible. Why is this important? Because we clearly want that, right? We want our regression line to be as accurate as possible. We don't want big residuals, okay? We want to have accurate data that we can predict. On page 171, you can be shown how to do all this wonderful stuff on your calculator. I recommend you go through the process. We also have residual plot. Definitions there. Basically, it helps us see whether the linear model that we're given is a fair one, really, if it's an accurate one. How to do this on a calculator is on page 125, 176. I recommend you take a look at that. Standard deviation residuals and the coefficient of determination are explained, and here are the formulas. R squared is the coefficient of determination, which you've seen. And then standard deviation of the residuals, you should have a, it should look familiar to, right? It looks like standard deviation of everything else. If you haven't already, I'd pause this video, write down everything in the formulas. This is how to calculate the least squares regression line depending on what information you have. Slope, your b value, is your r value times s sub y over s sub x. What does that mean? This is your standard deviation of your outputs divided by standard deviation of your inputs. And the y-intercept is just a equals the mean of y minus b times the mean of x. That'll get your y-intercept. We'll do examples with these and some of the other formulas we went over here in class. This definition of outlier. Obviously, we talked about outliers a lot in this class so far, but this is mostly talking about values that lie outside of your pattern or your regression line, right? They may have large residuals, particularly if they're extremely big or smaller in the y direction. Influential is an observation, is influential for a statistical calculation. If removing it would markedly change the result of the calculation. Points that are outliers in the x direction of the scatter plot are often influential for least squares regression line. So if you remove one value and it changes your data drastically, that would be influential. Thank you for watching us, and we'll see you in class.